Thank you for joining us for today's digital discussion, Long Duration Energy Storage Enabling High Penetration of Renewable Energy. Part of our Road to New Orleans series leading up to SPI, ESI, and Smart Energy Week this September 20th to the 23rd in New Orleans. Here you can find upcoming digital discussions, smart energy market tours, which are our traveling outdoor exhibitions, book and movie club discussions, as well as fun New Orleans-themed activities you can do at home. Today's participants can use the special discount code on the screen to save on a full conference pass for SPI, ESI, and Smart Energy Week in September. Visit smartenergyweek.com to register today. And now, let's welcome today's panelists and moderator.
Hi, welcome again to today's session. I'm Leslie Ponder, and I'm the Technology Portfolio Director for Black & Veatch's global distributed energy business. The future of energy storage is embedded deep in Black & Veatch's past. For over 100 years, our water experts have been engineering pumped hydroelectric storage to balance supply and demand for conventional and coal and nuclear plants. Since 2000, Black & Veatch has been working with equipment providers and developers of energy storage installations covering a variety of emerging technologies, things like compressed air, energy storage, flow batteries, and hydrogen fuel cells. I'm excited to be here with you today to lead a discussion on long-duration energy storage. The world is now at the beginning of a third industrial revolution. The last one was driven by mechanization. This one is being driven by decarbonization. I'm here today with Melissa, Eric, and Richard to discuss how long-duration energy storage will accelerate and support this new industrial revolution. To set the stage, let's review how storage has played a role so far in transforming our electric grid. Next slide, please. To date, the strongest growth driver for renewable energy has been the affordability of new electricity generation. While this driver will persist, a second driver has emerged. That's the increasing demand for clean, green, sustainable electricity. This demand is being driven across the board from federal and state governments, providing regulations and incentives, to commercial and industrial sectors via sustainability pledges and corporate goals, and ultimately from end-use consumers that are demanding sustainable, reliable, affordable energy. With the introduction of bulk and distributed scale generation like solar and wind, the need arose for grid support to mitigate the impacts of these variable energy sources. The power grid requires supply and demand of electricity to be balanced. For every electron generated, one must be used. Since the wind doesn't always blow and the sun is not always shining, other technologies like energy storage were required to fill the gap. The leading storage technology is lithium-ion batteries, and they dropped below a market entry price point around 2015. Since then, lithium-ion batteries have been pulling ahead in the energy storage horse race as prices decline due to the increased market penetration of electric vehicles that use these types of batteries. Today, that same lithium-ion battery technology is being used on the power grid, transforming power by turning variable renewable electricity generation into firm dispatchable generation. How does storage support the grid? Well, energy storage has been used as an effective technology for a variety of use cases that include things like energy shifting or moving the dispatch of electricity to the grid from when it was produced to when it is needed to support the load. Capacity in the form of peak load reduction to deal with demand spikes, and grid firming services to deal with voltage fluctuations and other system challenges associated with variable generation sources. Lithium-ion batteries perform these tasks extremely well and cost effectively for shorter durations, generally between up to 4 to 6 hours. But as firm conventional generation sources continue to be removed from the grid and are replaced with more variable renewables, the need for longer duration storage that extends past 6 hours is rapidly increasing. While it is technically feasible for lithium-ion batteries to extend their support, today's economics just don't work. Experts generally agree that lithium-ion batteries are going to hit economic limits for long-duration storage requirements, even if it's just related to the base price of raw materials. As the need for storage extends to support shifting power for longer durations, other technologies will need to step in. Looking ahead, Black & Veatch sees that lithium-ion batteries will continue to provide value for energy storage solutions in shorter duration use cases of up to 6 hours. Beyond that, other types of batteries like flow batteries are often more economical choices. In addition to batteries, there are many developers bringing forward new types of storage technology to support durations measured in days, weeks, months, and seasons. We're going to meet some of them right now. Our panelists are going to introduce themselves and tell you a little bit about long duration storage technologies. I'm going to turn it over to Melissa now for her introduction.
Thank you, Leslie. Next slide. Again, thank you. Very excited to be here to talk about Malta and talk about long duration energy storage in general. My name is Melissa DeValls. I'm the Director of Commercialization for Malta. I've been in the energy industry for my entire career, coming on 20 years now. Most of that time has been spent as project developer, business developer, mostly for small startup type companies. I also spent quite a bit of time on the utility side and originally come from a maritime background. Next slide. So I think, Leslie, you covered very well, all of the aspects of the energy landscape that are really evolving and shifting and shifting rapidly at that. And we really, again, completely agree that with the acceleration of renewables penetration, load growth from electrification, the need for long duration energy storage as distinct from shorter duration is really, rapidly being recognized. And, in order to meet the need, I would just suggest that, that the time is now to be bringing these technologies to market. Next slide. So just to quickly give a sense for Malta, who we are and what our particular technology looks like. So our core product is a 100 megawatt, 10-hour solution. Now the 10-hour, I'll get into this in a moment about our ability to scale outside of that and with relative ease and very cost effectively. But before I get into that, I do just want to quickly explain how our technology works. And how a Malta system stores energy is essentially across a temperature differential. On the high side, we have a molten salt, which many may be familiar is utilized primarily in the concentrated solar industry. We have on the low side a low temperature coolant, and in between the working fluid is essentially air. So just to maybe focus on the discharge side for a moment. What we essentially have is very familiar turbo machinery running a generator, and we have air running through that turbine. And it's essentially think of a gas turbine without the combustibles. So you have air running through a turbine that is essentially running a generator. And that is how a Malta system stores energy in a temperature differential, runs air through a turbine, and sends it back out onto the grid as needed. It's noteworthy that some of these characteristics or some of these component subsystems drive a lot of the high value characteristics of a Malta system. So example being with having rotating machinery, we have the opportunity and ability to provide rotational inertia to the system, which we view as being an increasing value point, especially as more and more base loaded thermal generation does come offline. Also want to quickly touch upon, and I mentioned it earlier about scale. So when you look at a Malta system, although our base system is focused at the 10-hour, our ability to scale from 8, 10, 24 to week-long solution is all about the size of the tanks. It's all about the amount of salt, essentially, or the amount of coolant fluid that we have storing that energy. So it effectively allows us to not have to stack things, as it were. So we don't have to put a plant on top of a plant. We have our 100 megawatt turbo machinery, and then the tanks will decide if the system need or will be designed as such for a 10-hour need or a week-long need. So it effectively gives us a lot of flexibility from that standpoint. Our system also has useful thermal energy as an output, which I think has a pretty unique characteristic and opportunity with respect to broader decarbonization, and effectively drives system efficiency when that thermal use can be, when the thermal can be used, it drives efficiency over 90%. It's not a requirement of our system. We do operate as standalone, but when we can find a thermal host, all the better. A few other points quickly: flexible siting and long asset life are things that are really core to the product that we have. Next slide. So from an application perspective, of course, here we're really focused on renewables firming, and true to form, we too, as a company, are quite focused as renewables firming being a top priority application for us. It's not the only application. In fact, we have a lot of customer discussions happening where, involving a lot of other things, including things mentioned here like T&D deferral and so forth. Next slide. You have to sort of click down until you get the. Here we go. So as you're sort of clicking down there, what is shown here, and I think it is maybe an important point to bring forth, is that you have to keep clicking. I'm sorry. There'll be probably 4 or 5 clicks you'll have. So 100% renewable energy is something that I think has become front of mind for some time now, but very, very quickly the focus is increasingly on 24/7. So essentially, I think you need maybe 2 or 3 more clicks. I'm sorry. So 24/7 renewables, implies the requirement for long duration storage. So what that means is if the grid is to look as though you have, renewables supplying generation on a firm 24/7 basis, this is a simulation over a period of 7 days with a profile where you can see, hey, maybe the wind is not blowing for a number of days. And then it's blowing a lot over another coming set of days. So you have both gaps and you have waste, and that's really where duration can really fill a need, from the ability to have a reliable, resilient grid that is also supplied by renewable energy. Next slide. The point to take away from this particular visual, and one that I would say that we often say, is that there's no single technology solution to the needs of the future grid system, and the way that we view ourselves is as complement to other solutions out there, and really we've designed our product to try and fill what we perceive as a gap, and really a gap driven by a need within the market. Next slide. And I'll just end by saying very quickly that our view truly is that the need for storage, it's a global need, it's a global opportunity, and as distinct from just storage alone, storage at duration is increasingly recognized as the key need and driver, throughout the various markets, including of course North America, which is a primary focus for us, as well as Europe. Thank you.
Thanks, Melissa. Eric, why don't you introduce yourself?
Excellent. Good afternoon, everyone. My name is Eric Steinley, and I am the Vice President of Project Development for a company called Rye Development. I have about 20 years of experience in the development of new hydropower, primarily in North America. So Rye Development, we are a hydropower company based in Boston, Massachusetts. We're backed by institutional investors, and we have a portfolio of projects across the US that includes new generation, primarily comprised of constructing new hydropower at non-powered dams. May come as a bit of a surprise to this group, but only 3% of our dams here in the US have hydropower facilities on them. And also pump storage, which I think everyone agrees is the sort of original long duration storage technology. We can go ahead and switch slides. So at Rye, we have initially focused on two projects in the Pacific Northwest, in Oregon and Washington State. Specifically, these are projects that are often referred to as closed loop pump storage hydropower systems, with two newly built reservoirs with water that's purchased from a local utility, and or the use of water rights that are existing for the initial fill and operation of the system. So specifically, we have a 400 megawatt project called the Swan Lake Project that's fully permitted, that ties into the existing AC transmission system near the Oregon-California border. And then a second 1,200 megawatt project just about 90 miles east of Portland, Oregon, called the Goldendale Energy Storage Project. And these two projects provide 9 hours and 20 hours of energy storage, respectively. So I think everyone knows pump storage isn't new. Of course, the first project was built over 100 years ago, and there's a number of operations in the US. So I don't need to talk too much about the technology because I think people are generally aware of it. But I would like to just mention a couple of things that are specific storage attributes, long duration storage attributes that are valuable to a long list of utilities in the Pacific Northwest who have historically relied on hydropower generation for a large portion of their resource stack. So the first is lifespan. So these projects have a 100+ year useful life, with the first major maintenance being every 30 years. Fast ramp rates and start times in the 20 megawatt per second range. No minimum run times. I mean, essentially just meaning they're capable of multiple daily mode changes. And high inertia, reactive power, including black start and bar support. We can go ahead and switch slides. So the next couple of slides, I just want to talk a little bit of sort of like how we got here. And it's a little bit Pacific Northwest centric, and that's sort of where our projects are. But I think this same information is now being spread out and looked at in a variety of markets across the United States, and certainly in places like Europe that are well ahead of the US when they're thinking about storage and decarbonization. So for us, really, the popular demand and policy that really started in California 20 years ago has expanded north to the Pacific Northwest. And so a long list of utilities are now facing, okay, not only are we integrating a lot of solar and wind, and of course it's great and there's a lot of support for that, but we're seeing impacts on our system, and now we're decoupling coal, and also have the inability either by policy or again by popular support to add any new thermal into the system. So what does storage look like, and particularly how does long and short duration storage work? Go ahead and switch slides. So as we really started down this path about 4 years ago at Rye, what we started seeing was sort of the initial Pacific Northwest utilities modeling what it was going to look like to have no thermal or no new thermal in their system as a capacity contribution, of course, with coal coming offline. So the main takeaway from this slide really is the large capacity deficits that are facing the Pacific Northwest. Again, this is a similar thing that you can look at across the United States as well, as they confront similar challenges. And what has been found in utility after utility is that anything less than 6 hours originally, and now it's crept up to 8 or 9 hours, from a storage standpoint, doesn't really count as meaningful capacity. So that's where our resource fits in. And again, I appreciate the opportunity to participate in the panel and look forward to questions.
Thank you, Eric. And last but certainly not least, Richard, why don't you introduce yourself?
Thank you. So I'm Richard Brody. I'm Vice President for Business Development with a company called Quinet Energy. I just joined Quinet about a month and a half ago. Like my colleagues, I've been in distributed energy and energy storage for around 20 years. Prior to this, with companies in energy storage and flow batteries, as well as other forms of energy storage. Let's go to the next slide. So Quinet is also in the pumped storage business. We like conventional pumped storage. We think for all the reasons that Eric outlined, it's a very versatile and effective storage technology. It's responsible for 94% of the energy storage in the world right now. But it's a hard project. It's a hard technology to deploy on a site flexible basis, and it's become a challenging technology to deploy in terms of permitting and project lead times. So one of the things we were looking for, that our company was looking for when it was founded, was ways to bring the benefits of pumped storage to the technology on a more distributed and a more effective basis. And so what we've done is essentially we're taking pumped storage and turning it upside down. So rather than pumping water up a hill and then having it come back down through a turbine to generate power, we're injecting water into the subsurface, into the ground, where we're able to hold the water under high pressure, what we call a storage lens, and then release it when we want to generate pressure back up through a borehole, through a turbine to generate power back onto the grid. What we're able to do with this technology is a number of things. So first of all, we make pumped storage a much more modular technology. So we can deploy it in a much more modular, scalable fashion from single-digit megawatts all the way to projects up in the hundreds of megawatts. It's terrain independent. We don't need mountains. We don't need hills to do this. We can achieve storage pressures. For example, in one project, we achieved storage pressures at 1,200 feet below ground, with 1,200 at a storage lens 1,200 feet below ground, equal to the pressure you'd get from a 2,000-foot mountain. So essentially, we're creating effectively a mountain in the middle of a prairie. Much lower, and with a much lower surface footprint compared to traditional pumped hydro. We're able to do this at a very low cost, half the cost of conventional battery storage and pumped hydro, with the potential to go even lower. And one of the nice things is these are costs for 10-hour systems, but we have the ability to go to 20 and 30-hour systems at only marginally higher cost, because all we're doing is essentially enlarging our storage lens and slightly enlarging our storage ponds. So we really have a very, very low cost of marginal energy, which I think makes us well suited towards new forms of renewable and its integration, especially the more challenging parts of renewable integration, for example, with wind. In terms of the geological applicability of the technology, we could apply this over a very broad geologic footprint in North America. We've identified, really, it's most of the rock in North America, over 100 terawatt hours or hundreds of terawatt hours of potential projects in the U.S. One other nice thing about the technology is we don't need to create new supply chain, new factories. We're able to use conventionally manufactured pumps and turbines for the topside equipment. For the subsurface work, we're able to use the current existing oil and gas industry workforce in order to do this. And really the highest risk area here is actually not commercial, since all those are well understood. It's really just the engineering of the storage lens. One other aspect here, which is important, I think, from a policy point of view, is that because we're using existing manufacturing workforces, and especially the workforce in the oil and gas industry, we're helping create a path for transition for the oil and gas industry workforce toward clean energy jobs, and that's a story I think that really meshes well as part of the clean energy transition. Next slide. So we're active now with 4 active wells in which we've consciously chosen to look at different geologies in different markets where we think there are going to be strong markets for energy storage. So we're in New York State, with a well in the center of the state in Chenango County. We have a well in Texas near San Antonio. We have a project in Ohio and a project in southern Alberta, supported by a variety of government agencies. We're thankful for support from NYSERDA, the Department of Energy, as well as Emissions Reduction Alberta. We're looking to expand into other areas. California is a high priority. We've identified sites there and hope to be expanding in California certainly within the next year. Next slide. In terms of just a little bit of a peek in terms of how the technology would look in practice. So this is a rendering of how our topside unit, what we call the hydropower unit, would look in a typical solar configuration. So you see the pipe coming out of the wellbore into the pumping and turbine machinery contained in what we call our hydropower skid. This is about a 2 megawatt unit, and we would place these strategically around a solar farm. And if you go to the next slide, please. Here's a rendering of how a system would look at scale for approximately 100 megawatt solar project with 200 megawatt hours of Quinet storage, so 20 megawatts at 10 hours. You can see we've got the pumping and generating units spread out throughout the solar farm, with the storage ponds for the water concentrated in 2 areas. So we're all excited about the technology and interested in answering your questions about how we see this applying to the market.
Thanks, Richard. So we're going to jump right in. I'm going to start us off with a few questions, and then we'll open up to the audience questions. So Richard, I'm going to start with this first question to you. What are some of the grid problems that your technologies will help solve, and what market changes or adaptations, if any, are required to drive adoption?
Yeah, so I think my colleagues have really covered the problems that we're addressing. So they're in 3 broad buckets. The first is everything related to renewables firming and integration. The second is kind of the other side of that is storage as a resource to relieve transmission and distribution congestion, or storage as a T&D resource. And for me, the third area that we haven't talked a lot about, but I think is really important for long duration storage is resiliency, particularly microgrid resiliency. Whether these are government projects or private sector projects, I think these technologies really have great potential for providing much stronger resiliency for critical installations. In terms of the market changes, long duration storage, the basic value proposition for long duration storage has always been some type of an arbitrage. But as we get higher penetrations of renewables, energy itself has less and less value, and the issue becomes not your payment for energy, but payments for flexibility. And so as we think about market changes, we need to see payments for, well, first of all, much more flexible use of energy storage. So first of all, that's, throughout the whole grid, the ability to use storage as both a regulated and a non-regulated resource in the wholesale markets and in the regulated markets. That needs to be easy so that the ratepayers can realize the full value of these new technologies. And at the same time, we need to see tariffs themselves that reflect payments for flexibility. And there are many ways to do this. Certainly capacity payments are a big area, so larger capacity payments, more flexible capacity mechanisms. Things like the clean peak incentives that we're seeing in Massachusetts, another way of introducing market changes to the benefit of long duration storage and ultimately the ratepayers. In a number of places, we're talking about imbalanced reserve products where the market is able to contract this kind of storage in the day-ahead market. And of course, we've talked about frequency regulation, ancillary services, particularly for technologies, I think like all 3 of ours, that have the potential to provide rotating mass and inertia to the grid. So lots of opportunities here, and there's lots of work going on in a number of places, in a number of trade associations. I should make one plug, kind of a shameless plug for the California Energy Storage Alliance. I'm board chair there, and we're doing what I think is some pioneering work in California on these new tariffs.
Great, Richard. Those are some really good points. Does anyone else have something to add?
No, I think we are in violent agreement on all of the points that Richard made, and I think he covered it very well.
I agree. I saw a lot of head nods.
Yeah, that's great.
Okay, so Melissa, I'm going to throw the next one to you. When you're talking to customers that are dealing with the transition to cleaner energy, what are you hearing, and how are they thinking about storage duration?
It's interesting. I think that, where initially one might think that there would be, some need for education to, the difference between what the familiar sort of anchored 4-hour lithium-ion solution relative to what, a company like Malta provides. those conversations are actually much more all along the lines of the customer saying, no, I recognize I have this need for duration. And that's covering the gamut. That's, not only from the perspective of, hey, I know renewables penetration is coming. I know that I'm going to have to be dealing with this, but it's also interestingly being driven a lot of conversations being driven by resiliency and reliability needs almost more than anything. Every time that there's some catastrophic event, Texas, California, in more recent times, it sort of highlights this need for what are the assets that we need to further grid harden. So it really, customers in different markets from, be it regulated, deregulated, vertically integrated, other, are really seeing that there's a huge value for long duration storage. And it's really being reflected in those conversations. And in action, I think there are more and more of our customers are ready to move. They see that the need is, essentially to act now to meet the needs that are coming very soon.
Great. Anyone else have something to add?
I would add that, I touched kind of on our projects in the Pacific Northwest, but if you expand out across the US, utilities and regions of the US, I think are just grappling with the scale of which that they're going to need to address storage and provide capacity and really be able to deal with some of those events that Melissa described. And are also having to consider, I think, a lot about how transportation is now linked to the grid in some capacity and plan around that. And there are portions of the US that are really struggling to get an understanding of just how we're going to accommodate really with any kind of storage, short or long, whether it's complementary or not, those types of capacity and energy needs moving forward. So again, to kind of Melissa's point, it's good, to be able to have these technologies that complement each other, because it's going to take a little bit of everything to get this done.
I agree. That's a really good point with fleet electrification and really the electrification of everything. Just being able to serve that additional capacity through existing lines, or at least through grid lines that are constrained for growth by just sheer volume of how much work you can get done at a time. The ability to shift and utilize storage of all different types to help spread that load across time, I think will be really, really important. So Eric, can you talk about any other decarbonization goals that long duration storage can address?
Yeah, I can be a little bit biased here for a minute and talk about sort of where we've been on the West Coast. To be frank, our real interest in these projects came about a few studies that were done by NGOs dating back almost 4 or 5 years ago on essentially a low cost, non-gas way to begin to decarbonize. And of course, pump storage, and it was pointed out earlier by Richard and Melissa that, these are somewhat constrained resources in where they can be sited. But for our projects and pump storage, at least on the West Coast, these are storage assets that, to a large extent, utilities are very familiar with. They have a lot of hydro in their system, and they've been using them very effectively and have continued to do so, at least until real recently, to balance a lot of additional wind and solar coming onto the system. So not only is it a sort of a low cost option for providing storage, providing capacity, it's one they're pretty familiar with, and to some extent excited to understand that they're going to have additional hydro flexibility, and not in the form of large new dams or peakers on the rivers, but essentially a closed system on the landscape that they can utilize in ways that they haven't been able to in 3-4 decades. So
I can add there, and I think kind of build on Eric's comments, because I think all three companies really, it brings up an additional subject, which is the workforce, right? And all three companies build on existing workforces and existing capabilities in the U.S. because, one of the big questions, of course, with the clean energy transition is, where's my clean energy job, right? What is this going to do for me? And if you look at certainly in our case where we're helping the oil and gas workforce transition to clean energy jobs, but all three technologies really utilize manufacturing supply chains that already, and factories and businesses that already exist in the U.S. We don't need to create new battery factories, new electrolyte manufacturing plants, new chemical plants. These are industries and jobs that already exist and in which American workers already excel. So I think there's a great story. There's a great clean energy story in that from all three companies.
Yeah, and if I could just quickly add, I mean, it is very front of mind for us. This people-centered transition is a necessity. In fact, we have a study that we're doing right now with Duke on looking at how to repurpose one of their coal plants, and that's inclusive of anything from equipment that can be repurposed and how from an employment and community perspective that we can sustain and be part of fostering that just transition. Just going back to the prior question. I'm sorry, I lost that one. So anyway, so we can move on from there. But I just to echo absolutely the labor element. Oh, I'm sorry, I got it back. From a decarbonization perspective, sorry, I just had a moment. We're pretty excited about the opportunities on the thermal side. And this is where we're having some really interesting conversations because the hard to decarbonize sectors have a need for the type of thermal product that we produce. So when you think about pairing a Malta system with a renewables product, and in the end you have green heat or green steam and green coolant, actually, it can be a pretty attractive opportunity, if we find the right customers and site. So I do just want to say that we view our product as having a role in decarbonization broadly. Our primary focus is the electric sector, but we're also finding that there's some real opportunity to help on the more hard to decarbonize areas. And that includes things like district heating and industrial processes.
That's a really good point, Melissa. I know at Black & Veatch we're heavily engaged in decarbonization strategy and roadmaps, as well as project development, and really those secondary products that come out of some of these newer technologies are real game changers in what types of customers you can support from a decarbonization strategy perspective. So I do have one more question that of course you can all weigh in on, but Eric, I'll start again with you. What advice can you give for how to select from a variety of technology to meet your particular needs if you're a client?
So I think, start with a simple answer first. What is your resource area? Who are you serving? What are your challenges? And I think they're pretty different if you're a system that's almost entirely coal and less than 10% renewable versus, a system that started out being over 50% renewable, like the Pacific Northwest with existing hydro. So, start with what your needs are. And then, I think one question that comes up a lot as we're talking utilities, and it's mainly utilities, although there are corporate entities now that are interested in 24/7 power and starting to have interest in long duration storage, is considering a little bit of supply. So there seems to be a growing concern, and this is mainly elected officials, I would say at this point, on the grid relying on lithium ion or other sources that could compete with the electric vehicle marketplace. So again, starting with something simple. What are the resources that are available? What is the system that's in place? And to Melissa's point around, existing infrastructure and how Malta can play a role. or in the case of, Quinet, it's a technology that lends itself almost anywhere from scale. And certainly it's easier to site in places like the Midwest than a large pump storage project, right? Where we need a lot of, geography and geology to support it.
Leslie, you're on mute.
Oh, sorry. Anyone else have anything to add? If not, I will start. I'll switch us over to audience questions. The first one that I'm going to talk about is for each product, Malta, Rye, and Quinet, what is first the dollars per kilowatt hour for your targeted design size and duration? And then second, what is the incremental dollar per kilowatt hour for each additional hour of storage? And Richard, why don't we start with you?
So we will come to market for a 10-hour system at somewhere between $1,000 and $1,500 a kilowatt, which is $100 to $150 a kilowatt hour. We will, and those are just early projects. We will ultimately go much lower, way below half that. For additional energy, it's very low, $5 to $10 a kilowatt hour.
Okay, great. How about you, Eric?
Yeah, we're in the $200 per kilowatt hour range. And then, incrementally, I don't have that number in front of me, but it's pretty low, right? As you add those incremental hours.
Melissa?
Yeah, and I would say we're probably, fairly aligned to Quinet's costs, and our cost curve is fairly dramatic the more we go into duration. So the more energy we're providing, the incremental costs are, very attractive and competitive.
Okay, great. So our next question, if lithium ion gets a 10x performance improvement, does this shift or other shifts that will happen every few years get considered in your thermal and pump economic optimization models?
Let me answer that question, because I don't think it's a question of whether lithium ion's gonna have a 10x performance improvement. Lithium ion, the stationary storage market is leveraging off the huge investment being made in investment in automotive batteries, and those are being optimized right now for cost, for energy density, and for fast charge. Those are the things that really matter. What they're not being optimized for are cycle life. A lithium-ion battery for a car doesn't need to do much more than 1,000 cycles. The things that matter for stationary storage are cycle life and durability, and those are just not subjects of a huge amount of innovation. Now, that there could be more innovation, but if you look at all the projections for lithium-ion costs, even using the most optimistic automotive industry forecast, and then you translate those up, not from the cell level, but to fully installed system cost, none of those costs really rival the costs that we were just discussing. So that's the way I would look at that question.
Great. Anyone else want to weigh in on it?
I would talk about scale. It's pretty easy to talk about the scale of how much lithium ion and what that would look like, right? If you were going to ramp up and use that as, essentially the source or the majority source of storage in the system. And once you start talking about that, utilities, local communities, elected officials, they really want to see a suite of these resources, and certainly think about options that would have less of an impact on the landscape just spatially. So
I would agree, and I think one of the things that your products provide that you all kind of touched on is inertia, which lithium ion will not provide, which will be really important for system stability as well. So I have a question for Quinet. What is the scientific evidence that rapid cyclic pressurized cycles of the geology has long-term stability compared to geologic timelines?
Okay, so I'll practice some unlicensed geology right now. So we operate well within the elastic properties of the rock that we're pressurizing. So we stay. If you look at the way this is typically understood, we stay below, essentially way below the threshold, below essentially 70%. We stay way below 70% of the rock's threshold elasticity, and can cycle there for what by what is considered consensus among geologists. Essentially, we can do hundreds of thousands of cycles within the range of flexibility of the rock. So we're pretty confident on that point.
Great. So the next question is, what market and policy changes are required to attain viability? Standalone storage does not qualify for ITC MACRS. Is this a priority?
ITC is a priority, certainly. Yeah, and
Exactly.
it may very well happen in the current bills in Congress.
Yeah, I completely agree, and I think Richard also touched upon a number of other areas of value points that would be great to see sort of reflected in the market. But I think that's where these conversations become really important in terms of sort of educating across the landscape of customers, stakeholders, policymakers, regulators, et cetera, just to have our sort of collective approach and our collective set of solutions be enabled. So I would echo what Richard said.
Yeah, and I would just add, I believe Eric touched on it earlier. Variety is definitely going to be important for how we deliver the grid of the future and decarbonize across the board. And a lot of these technologies are going to need support to meet the pretty aggressive goals that the globe, quite frankly, has to meet climate change and sustainability standards. So I think all the support for these individual storage type technologies will be welcome. So another question, what are the lifespans of your technologies and what is the cyclic or annual degradation? Actually, Richard, why don't you start and then I'll go around.
So our projects are at least 40 years. And there should be no degradation in a properly maintained system.
I'll jump in. Ours are 30 plus years, and we also do not have an issue with degradation. Neither the salt nor the coolant side have degradation from cycling.
Great.
Yeah, pump storage is 100 plus year lifespan and no measurable degradation.
Great. Let's see. I did have a question for Malta. What is the typical range of electrical efficiency of the Malta energy storage solution, not considering thermal, and then the overall efficiency when also considering the usable thermal energy?
Yeah, so our electrical efficiency as standalone is right about 60%, but when you include the thermal side, it goes up above 90%.
Okay, great. Let's see. So the next question is, what does the end of life look like for your technologies? Are they recyclable?
I can note for ours, it would be, even if you want to, you could continue, we probably even beyond the 40 years to operate our systems. But if you wanted to decommission the system, you would simply decommission the borehole. You would fill it with cement and with the surface pond that we keep the water in, you would either leave it there. Farmers like to have water features, and it improves the land. We can leave it there, or we could return the land back to the field that it was. And obviously take away the turbo machinery. So it's pretty easy to decommission. and there are no. I don't think there are any recycling issues. We're taking away. We're taking away machinery that can be that goes either gets reused or goes into the scrap market.
Great.
Yeah, it's similar for our closed loop pump storage projects. It's primarily just steel and concrete. So, at the end of the 100+ years, you could obviously repurpose and remove the steel. And, our projects, even though the projects are of significant megawatt size, the largest features are essentially 60-acre ponds on the landscape. So, those ponds could remain or they could be removed.
Yeah, and from Malta's perspective, I mean, the salt is, and as well as the coolant side, those are commodity products that can be recycled and reused at the end of the plant life. And otherwise we would have, your standard sort of turbo machinery, scrap metal, et cetera, that hopefully could be repurposed and recycled.
Great. So our next question is around business cases. What is the business case that you use to sell your products to customers, and how do you price these large projects? That's just a very narrow question. I'm sure we can answer that quickly. Richard, do you want to start?
I think we should leave that to our project developer.
Exactly.
Eric?
Well, and I think we've covered a lot of the business case, so maybe just cover that part. Pricing gets a little trickier. If there's anything that you have to add to kind of what is a compelling business case for your products.
Yeah, I think, the business case we talked about earlier is the demand is there, right? And the demand is increasing exponentially across the United States in areas that are considering decarbonization, especially when you move past 50% renewable in your portfolio, and it's relying more and more on intermittent sources of electricity, right? So that's your business case. I think for us, for interested groups, utilities like to own stuff. At least that's the mantra that's out there. But what's really worked well in the business case for us is offering a tolling type arrangement from the utility. So they bring their own renewable products. They have transmission rights, to your asset, and then they're able to define essentially the on-demand resource out the back end from your system. And then they don't have to take on the ownership risk. And it's sort of funny, right? On the one hand, I'm saying utilities like to own things. On the other hand, they don't want that risk. So I think it's that business case that is most compelling to people that are interested in long duration. I would say, though, I think that's going to change as we move here in the future as well. I mean, I think for myself and my colleagues here on this, we're sort of at the front end of this, if I want to be so bold in saying that. And everyone's going to be looking at this in some capacity, no pun intended, very soon. And so I think there'll be different vehicles, and Melissa and Richard both talked on some of those market changes, right? Even the ITC, if that was to pass, could change dramatically how potential people wanted to participate in it, which would change your market approach. Yeah.
I should just add, we entirely agree with that. We're coming to market in a variety of ways. So we're looking at tolling agreements. We're looking at developing projects ourselves, co-development. We're looking at selling services. So there are many different ways to do this, and I think it's going to evolve with the market.
Yeah, in a very similar way. I mean, we have we have tolling arrangements that we have underway, and we have similarly are seeing that because of where we are with respect to the state of the market, we are expecting to take on more risk on our end and have to put together instruments and partners to to make sure that we're, bringing forward to the market a product in a way that customers can sign on to it. So I would just, reflect and say that, we're similarly looking at and working with other development partners. We're working directly with utilities who are considering the system benefits value of what we're providing. And looking at that, I would say, importantly, not just from a what's the here and now time horizon and asset mix horizon, but really looking further out. For some utilities, it becomes important to a challenge really actually to for us collectively to work together to what's the system value from a grid mix 2, 5, 10 years from now, and really allowing that value to come forward today. So that's really critical.
Thanks for that. I would agree. I think those are all collectively, you had some really good points. Another question is for Malta. How important is it to consider existing thermal assets of varying fuel sources in short, medium, and long-term planning?
Yeah, no, I think this is a really important question, because I know we've been focused quite a bit on renewables here in this discussion, but our view really is that especially over the short and medium term, existing thermal assets, natural gas, nuclear, all have a really important role to play in reliability and resiliency. And we're actually working with we have another study that has been published with an entity down in Texas, who has a natural gas combined cycle facility, where we're looking at how a storage system can improve efficiency and cost for that particular system. So we really see that as the transition happens, it's not an overnight thing, and really optimizing and utilizing existing assets in the right way is it will be necessary, and we're very much in support of that. The coal industry faces, I think, a slightly different challenge for a number of reasons, be it, policy changes. In some cases, it has to do with the economic drivers that, new generation simply being more competitive, let's say, than coal. So they're facing, I think, a slightly different challenge with respect to the transition. And as mentioned earlier, I think we're all very, keen to be a helpful part of that potential transition as well.
Great. And I have one more question. What role has the Department of Energy or other governments played in developing your technologies?
I'll chime in. DOE has been a critical partner for us.
Yeah.
There's we have ARPA-E, ERE have both been very, very, very supportive of us, and we're very grateful for that.
Wonderful.
Yeah, I would just echo similarly. DOE's been a great partner in this for pump storage. Most recently, they did just issue the Pump Storage Hydro Evaluation Guidebook, which is a real cost benefit, sort of a decision analysis framework on why pump storage versus other storage options for utility planners and industry. So, and great to work.
I should also add, for both Eric and my sake, that WPTO at DOE as well has been very supportive.
Great. Yeah, and I would add our national labs are a real treasure and are really leading the way on energy transformation as far as research and development, and working with both utilities, developers, OEMs, and the government to kind of drive that into a cohesive plan. So I think that they're a key component to this process.
Yeah, absolutely agree.
Well, I think that brings us to the end. Thank you so much for attending. I'm sure if you have additional questions, that our panelists would be more than happy to answer those. So I'm sure you can reach out to them as well. And thank you very much.
Thank you.
Thank you for joining us today. Remember, today's participants can use the special discount code on the screen to save on a full conference registration for SPI ESI and Smart Energy Week this September. Visit smartenergyweek.com to get registered today. If you're interested in hearing more about long-duration storage, check out this upcoming session at SPI ESI and Smart Energy Week.